In this video, I will demonstrate how to correct for scanner tilt errors. These errors can occur if the scanner is miscalibrated or if you are scanning on an unstable surface like the top of a floating roof. So first off, how do we know we have tilt errors in our data? During visual inspection of our registration, we see that the scan layers are tight where we placed our fiducials. However, beyond that, the scan layers quickly start to deviate. I just want to mention at this time that correcting for scanner tilt is an advanced manipulation. You should not need to do this for typical projects. If I take two vertical slices of the tank, it is clear that something is not correct with this registration. We can see that the red scan layer is quite tilted, but the other ones don't look great either. We want to do fine registration again, but this time with the vertical tilt option enabled. Before we do that, we need to ensure we have horizontal fiducials at the top of the tank to help resolve the tilt differences. Once I have added the fiducials at the top of the tank, I can run snap fiducials. Once this is complete, I run the Align Tilt tool to rebalance the tilt errors between the scans. The Align Tilt tool will set the average tilt of the reference layers to plumb by rotating the model as a whole. This tool should always be run at the end of fine registration if you have modified the vertical tilt of any of the layers. In this scenario, the Align Tilt tool warns us that one of the scan layers has above average tilt error. If you get this warning, simply rerun the Align Tilt tool and omit this scan layer from the reference layers. Now, if we run Check Tilt using only scans 2 to 6, you will see that the average tilt has been set to plumb. Given that the tilt errors of these scans are in the 0.3 degree range, there is still a fair bit of uncertainty in the overall tilt of the model. If these scans were all that we had, this is the best that we can do given the information we have. However, if we have a set of scans that have higher tilt accuracy, in this instance the bottom scans, we can use these scans to further adjust the tilt. When we look at a cross-section of the top and bottom models, we can see there is still a slight discrepancy between the top and the bottom of the floating roof. In this case, it works out to be about 0.2 of a degree of tilt error that still exists in the top model. What we can do is we can use the match elevation tool to adjust the tilt of the top model using the bottom model. I'm going to define 4 areas to match. This will allow the tool to resolve the tilt error between the two models by adjusting the top model so that the elevation differences at each of the points I selected is equal to the thickness of the floating roof. Interestingly enough, if I run check tilt again on the top model, I find that scans 5 and 6 are near plumb. This means that these two scans were likely correct. If I want to rely on the sensor data, I could do a line tilt again and use these two scans as my reference layers. If we have any overlaps between the two models, we can further refine the elevation match between the top and bottom models by again using the match elevation tool. However, this time I'm going to define the surface I want to match using a polygon, which only adjusts the elevation of the top model and not the tilt. You may see that the top of the floating roof is above the bottom at some points. This is possible because the floating roof will typically deform and sag when the scan technician is scanning from above.